Hi, I'm Damien Harkin. This is a series about modelling a sheet metal bench top, such as you might find in a commercial kitchen. Our bench has splashbacks at the back and on the right hand side. In Chapter 1, we'll model the geometry of the bench. Let's start with the box command to form the actual bench top. We'll make the bench 700mm deep from front to back. It can be 1000mm wide from left to right and 100mm thick from top to bottom. It's good to keep it quite small while we're initially creating it, but this bench will be parametric and we'll be able to change the length and width to any numbers we like. I've drawn this box starting at the back, top, right corner of the bench. That's where the splashbacks will join, and that's the point where we would hold the bench when we're placing it into the corner of a room. Now we'll use the polysolid command to form the splashbacks. Let's set the width of the polysolid to 30mm. We can use an endpoint snap to pick up the corners of the box. Use a right click to finish placing the baseline. Now we can use the Control key to toggle the alignment of the polysolid. We will place the polysolid inside the line that we drew. Then to finish the polysolid command, we can set the height of the splashback to say 350. Now notice that the polysolid command has created two separate solids with a neat miter joint between them. We need them to be two separate solids because we're going to separately rotate the top surfaces. We don't want the cook to use the top of the splashback as a shelf. We'll set selection modes to select faces. Hover over the top of the splashback and select the rotate command from the quad. We'll rotate this surface around the axis of the back edge. The reference point can be a point on the front edge. We'll rotate the surface down 45 degrees. Now we'll spin the model around and do the same for the second splashback. Now we have the correct shape for our bench with splashbacks. We can union these three solids into one solid. Select them all and we'll select the union command from the editing toolbar. Let's hollow out the model. Select the Solid Editing Shell command. This command can remove surfaces, but for now we will keep all the surfaces. Set the shell thickness to 1.5mm. Now we don't want a full back on these splashbacks, we just want a lip at the top. So we're going to cut holes into the back of the model. We need to cut away most of the bottom of the bench as well. We're going to leave a 30mm lip around the front edge of the bench. I'll use the offset command to start this rectangle. Hovering over the rectangle, we can extrude the rectangle out to form a solid or inwards to cut away our model. I'll extrude it 10mm up into the model to cut away the base, but not the top surface of the workbench. Now we'll use the push-pull command to push the edge of this flange back flush with the inside face of the wall of the bench. When we press the Tab key, we can change the target of the dynamic dimension. So we can set the dimension between the edge of this flange and the inside face to 0. Let's save the model now. Now I'll spin it around and I can draw a rectangle. Because dynamic UCS is turned on, I can draw a rectangle directly on the face of the back of the model. Start the extrude command, push into the model, type in 10 and press enter. Now we'll clean up this cut using the push-pull command to force it flush with the face of the inside of the model. Again, we use the Tab key to move the dynamic dimension so that it's pointing to that inside face, and type in 0. We'll use the same technique on the back of the side splashback to clean that up as well. We have one more chore to do to clean up this geometry at the back. We're going to raise up the skirt around the back so that it's level with the kink in the front of the splashback. We can just snap to that point. Now we're dealing with very small surfaces, 1.5mm thick, on a relatively big model. So sometimes it's a bit tricky to get an appropriate view where you can see what you're trying to do. So bingo, that looks pretty much like the model we're trying to create. So we'll save the work now. Up till now, our model is a dumb solid. It doesn't know that it's meant to be sheet metal. But now we will use SM Convert to convert the model to sheet metal. This will maintain the thickness of all of the flanges. If we look at the mechanical browser, we can see initially there's nothing there, but when we run the SM Convert command, suddenly we have sheet metal flanges recognised by the system. So we'll save the model at this stage, and that's really the end of chapter 1 of making a sheet metal workbench. Thanks.
Download the free trial version of BricsCAD at www.bricsys.com and check it out for yourself.